Hello. So, hi everyone. I'm Sharmaigne. You can call me Sam, and today we're going to space through Python. So, before I start, I'd like to thank the PyCon Taiwan organizers for inviting me in the first place and for being so welcoming at my stay here. And of course, you guys for being here with me in this room today. I hope you learn something new and maybe get a boost of inspiration from this talk, the way I did when I was researching it like a few weeks ago. So without further ado, let's start. So I'm not sure if this little guy is like familiar to you, but this is Ingenuity. Her nickname is Ginny, and she's the first helicopter to ever fly on another planet. Now, she might look small, but she's a mighty machine. Ginny weighs less than 2 kilograms, so that's less than most of your laptops probably, and she's completely autonomous. NASA originally planned to have only 5 flights with Ginny because they weren't even sure that we could fly in an atmosphere that's as thin as Mars, right? But Ginny went far beyond that, making more than 70 flights in total over the span of 3 years. So clearly, she's a massive technological feat. Now, let's play a little game. Let's try to guess what programming language she was coded in. So raise of hands if you think Ginny runs with C++. No one? What about Fortran? No one? What about Python? Everybody's racing with Python. So actually, that's a trick question. So like most, like most projects with NASA, it doesn't only run with just one programming language. So tons of modules and tons of programming languages are used to make these projects happen. So as like someone who's not at this talk might expect, Ginny actually runs like the one that's actually programmed into Ginny is C++ because you need it to be super duper efficient, right? But for the data that actually comes back to Earth, the things that we actually make use of and sort of interpret, that's all run through Python. So data analysis and visualization, that's where Python shines with NASA. So the same language that most of us here use on the daily also help NASA scientists study data from literally another planet. So this is something that astronomers might tell you, which is that astronomy basically boils down to data collection, right? And Python is sort of the language of data science. And so before, I'm kind of going to interrupt the flow of this talk by explaining a little bit of my motivation for this talk in the first place. So you might want to think about what your most ambitious goal was when you were a kid. For me, it was to become an astronaut because I really, really wanted to go to space and to sort of explore all of these things that I can't do over here. But as I grew up, I realized that you can do that with so much more things, right? Like so many more people, scientists, engineers, and computer scientists do work over here on Earth in order to make these flights happen. And so what I found really fascinating was the fact that the work that we're doing can actually help NASA and help these astronauts make these flights happen. So I was getting bored of how Python was getting used around me. It was all like web web development and like app development. And so I was scrolling through the GitHub account of NASA and I noticed something very interesting, which is that Python was the most used language for the NASA GitHub account. So today, I kind of want to change your perception of NASA. So when you hear NASA software, you probably imagine rocket scientists coding in super optimized languages like C++ or Fortran. And that's true for flight critical systems. But the same Python that you use for side products or your homework is also at the heart of NASA's daily work, which is data analysis, testing, visualization, and even pipelines for Space Telescope. So the goal for today's talk is simple, which is that I want to inspire you to see Python beyond the everyday, into science, into space. Okay, so As I said, NASA's tech stack is diverse, but Python is the glue because it's the puzzle piece that connects engineers, scientists, and data analysts together. This is the stats that I was talking about. The top language is Python, beating even C and C++. And there are over 150 repositories primarily written in Python in the NASA GitHub account. So considering that there are only like 500 in the NASA GitHub account, that's like more than 1/4, I believe. So it shows that Python shows up quietly but powerfully in data analysis. So now that I've kind of given you the gist of how Python fits in the ecosystem, I'd like to sort of give a more concrete example. So we're going to go through 3 particular projects, NASA projects, the challenges that they faced, and how Python helped with that. So in order from left to right, we're going to go through JWST, which is the James Webb Space Telescope, the core flight system of NASA, and lastly, sort of a more general open source libraries for astronomy. So this is the James Webb Space Telescope. If you're on Twitter, then you might have seen this a few years ago when it was finally launched, because we've been waiting like 20 years for this to finally launch. And this is basically a very, very big mirror that they sent up in space to take photos and to show us things that we've never seen before in deep space. So it's like, if you've heard of Hubble, it's that, but so much more powerful. But the thing is, JWST doesn't produce images. Not really, right? It produces raw numbers, huge, messy data files. In fact, it produces like petabytes of them. So then how do we turn this messy data into this? Stunning photos of deep space. Well, that all happens through the JWST calibration pipeline. So the calibration pipeline is an end-to-end system for turning raw telescope data into science-ready files. So it's a modular pipeline with stages for different things, like checking if the data is complete in the first place, for detecting errors, calibration, and like higher-level science products depending on what your team actually needs. And it's written entirely in Python, and it's developed by the Space Telescope Science Institute, which is sort of like under NASA. And the thing about it is it's open source. So you can actually see all of the code in GitHub right now and like contribute it if you wanted. So this calibration pipeline basically ensures that all the data that we're getting and the data that we're analyzing are consistent and reproducible globally. So that's it for JWST. Secondly is the core flight system, which is actually the project that I first saw and motivated me for this talk. So the core flight system is NASA's open source flight software framework, and it's sort of one of the most important projects within NASA, right? Because it's the thing that powers real missions. So it's a thing that actually makes things fly. It provides building blocks for command processing, telemetry, scheduling, and data handling. And it's written in C, right? And it's also open source. So how does Python fit into this? Well, just recently, they actually added like Python support for like what you can code when you're in the space station. So since astronauts aren't necessarily computer scientists, like you have doctors, you have soldiers, you have whatever up there, when they need to write something within like in space, they needed to be fast and they needed to be accurate. And like learning really, really complicated languages isn't really good for that. So they decided to apply Python. And that's just sort of showing you that the fact that Python has a very easy syntax isn't like a negative thing about it, right? So yeah, astronauts use Python now. Next, Python libraries in astronomy. So I don't know if any of these look familiar to you, but the following libraries might be like NumPy, Matplotlib, SciPy. So those are some like data analysis, like data science libraries, and they actually also use those. That's one of the main reasons why Python is super useful in astronomy. But apart from those, we also have libraries that are specifically for astronomy. So, for example, AstroPy is one of the biggest libraries. It's a core package for units, coordinates, times, and I/O. And under that, from the same team, is AstroQuery, which lets you access online databases. So, as I said, as I might have said, the NASA data, like the things that we are actually getting from the things that they're funding, are actually mostly available online. So you can do your own analysis and your own work with it. So AstroQuery is one way you can do it. So you can access those databases directly in Python, and I'm going to show you an example of it later. LightCurve and SunPy are sort of more specific libraries. So they analyze solar physics or like light curves from Kepler or tests for exoplanet hunting. And so these libraries, they're not necessarily built by computer scientists. Most of them are built by and for astronomers, but they're accessible to anyone learning Python. So that's another thing, right? Like even if you're not a computer scientist, you can it's pretty easy to build a library in Python. It's that accessible, and that's a big part of why we use it. So I was gonna do a demo, but like demos always fail. So let's just like go through some code here. So I'm gonna show you how easy it is to sort of get started into doing your own data analysis work through Python with real NASA data. So once you have AstroQuery on your project, you can literally just have that one line, and that's going to fetch the Kepler 10, what's it called? Kepler 10 data for you. So after you get the data, oh, the image is not loading. Sorry about this. Okay. Okay, well, I wanted to do a static thing so the demo doesn't fail, but it still failed anyway. So once you get the data, you can then download it because you don't want to sort of do your data analysis like with API fetches, right? Because it's gonna take a long time. So you download the data, and then you can use the library that you've probably already used before, which is Matplotlib. That's also still the library that astronomers and NASA scientists use. So with those simple 3 steps, you can start your data analysis. You can create a scatter plot of the data that you got from the NASA datasets. Okay, so we've talked about some of those examples. And now let's think about like what connects all of those, right? Like why use Python in the first place as opposed to all the other programming languages that NASA already uses and supports. So these are 4 of the main reasons. First is it's very readable. So it's very readable, and this is like sort of mixing into the third one, which is its cross-field. So since the code that we're dealing with here will be touched by a lot of people, like it's not only data scientists, it's not only astronomers who are touching it, not only computer scientists, it needs to be something that everyone can understand and everyone can work with. And so that's why Python is sort of an ideal thing for that, right? Like and the fact that like, what are the cons of using Python, right? Maybe you're gonna say like, yeah, it's slow, but like processing takes a long time. Anyway, even if you like data processing takes a long time, even if you use C++. So it's sort of for non-flight critical systems, it's sort of better to use Python because you're making sure that everyone understands the code. And second is what we discussed earlier, which is it has powerful libraries for data manipulation, for astronomy, since everybody's sort of contributing to it in the first place. And lastly, rapid prototyping. So I don't know if you got to experience Miss Chuk's talk yesterday, but something she said really stuck to me, which was that when we ask the question of is Python slow, we say yes, because we think that Python is low in terms of performance, which is true. But Python is very, very fast when it comes to turning ideas into reality. And so that's a very good thing about Python. You can rapidly prototype things that you would otherwise take such a long time to do in the first place. Okay, so after we've talked about, wait, I'm so sorry, I need one. Okay, so after we've talked about all of those, right, you might be hyped to see like, okay, so what can I actually do to contribute? Like aside from using the tools that these people have made, like can I actually contribute to the tools in the first place? And of course, like NASA is very much hashtag FOSS, so free open source software. So as Carol Willing said, which is one of the core, I think one of the core members of Python, she said, much like dropping a pebble in a lake, your small contribution ripples out to have a much larger impact. So if you can see there's a little badge. That's actually a GitHub NASA badge, helicopter badge, I think. And they gave that out to developers who contributed to open source software that was used as dependencies for the Ingenuity project. So when Ingenuity first made the first flight in Mars, the open source projects from like years ago who never thought that their code would help us go to Mars actually got a little badge for their contribution, and that might be you someday, right? So, like, okay, let's contribute to open source, blah, blah, blah. But, like, how do we actually do that? So, here's a step by step sort of. So, you can visit code.nasa.gov. There, you'll see 500 plus NASA approved open source software projects. You can find one that you're interested in and you can contribute to it. Or if you don't find anything, you can make one yourself. So you can submit a proposal, they'll check it, and if they approve it, if it gets approved, then it gets added to the NASA GitHub repository. So yeah, that is how it works. So let's sort of put this talk to a rest, to a conclusion. Let's land this plane. So Python doesn't really literally fly the rockets, right? But it powers the science that makes exploration possible. So it turns numbers into breathtaking discoveries. If you get a takeaway from this talk, I'd like it to be the fact that the code you write, the same Python that you debug at midnight, can ripple into something far greater. So explore NASA's APIs. All of their information are like open source. Fork a repository, and maybe, just maybe, your Python will help humanity explore the stars. So again, I'm Sharmaigne. Thank you so much for listening to my talk. This is my LinkedIn if you wanted to connect. My email is there and you can just reach out to me if you wanted. So thank you once again. And I think I still have time for Q&A.
You use the meet microphone, please switch to. So our Q&A session starts. Everyone is welcome to enter your questions through Slido, or you can just raise your hand and ask directly. Does anyone have questions? Okay, I have a very simple question for Sharmaigne. Among your research on NASA's space project, what project do you find most exciting or very easy to begin with? Okay.
Okay. I think what I find most exciting is probably the one that I like sort of demoed, which is Astro Query, because of the fact that it lets you sort of play around with like NASA data, right? So if you think about it, like NASA projects take so much money, take so much time to do, so much effort, and the fruits of that labor, the data that they get from that, they're just putting out there sort of like for everyone to see and for everyone to use. And I found it so fascinating that like I don't have to be part of NASA to use that kind of thing. And the fact that like I can play around with it directly through Python is something that I find super exciting. And I think that's a very good way to start if you'd like to like play around for a little bit before you sort of get into the meat of the code. Okay. Can we use Python to find extraterrestrial life? Okay, so disclaimer, I'm not like a part of NASA or anything, so I can't say anything like definitively about this. But if we were to find extraterrestrial life, then it would probably be through data analysis, which, as I said, like mainly uses Python. So that's very possible. Maybe like Python will post someday that hey, Python found aliens in wherever. So yeah, that would be very exciting. Thank you for that question. Who are the main contributors of NASA GitHub repositories? So there are actually like a ton. I can actually show you right now. Do I have the GitHub open? NASA GitHub. Okay. So I'll show you the NASA GitHub account right now. So as you can see, top language is Python. There are a bunch of people here. So the way this happens is like there are organization members, which are all NASA, what are they called? Employees. So you can't be a member of the organization if you're not an employee, but you can contribute. I'm not sure where to find the like main contributors of the whole thing. So like each project has a different one. And also I just wanted to say that like this is not the only NASA GitHub account. So yeah, you can see the contributors here. So this is not the only NASA GitHub account. There are actually more for like subsidiaries and stuff. So for example, the JWST one is in another account. Could you share some interesting open source projects in NASA? I'd love to talk to you about that, but like I can't look at them. I can't like find them right now. So maybe you can reach out to me later and I'll show you some. It's super cool. Okay, this one. How do NASA handle the problem of Python low performance, especially when processing massive data collection? Honestly, they kind of just wait. They just wait and then like a bunch like they use a lot of computers. So if you look at like how astronomers sort of use Python, it's mainly for the fact that it's really really convenient to use, and as I said, like there's so much support for it. So as opposed to like yeah, it takes a long time for it to process, but as opposed to having to wait for the tools to be built in another language, right now that's what they're using. So like honestly, if Python was faster, it would probably be a perfect language. Next one. Okay, I think those are our questions. Do we have any more? You can raise your hands if you have any. Yes, sir.
So there are many data you show us, but we are not in the same field. How do we know that which kind of data we want to look at?
Right. That's true. So like how do you I think the question is like how do you start to find sort of what interests you when you're not really like in the field of astronomy. And that's kind of difficult for me to answer because like I'm kind of the opposite. I liked astronomy before I liked computer science. I feel like it's a matter of exploration. So I'm gonna try to find the nasa open data. One thing that's possible is like you can start with a very broad with a very broad notion of what you like. So do you like planets, galaxies, whatever? You don't have to be very technical in the first place, and sort of just explore that, because yeah, it's sort of hard to get into it when you don't understand the lingo yet. Oh, it's not loading, sadly enough. But I think it's pretty well documented, I'd say. There are also like something that might be more interesting for you if you're just starting out and like you're not that interested in the like the numbers and stuff, might be processing photos, because photos are so much more interesting. Like looking at like JWST images and stuff might be better. And then after that, you can transition into sort of numbers and data crunching with the NASA API. Oh, I didn't say it earlier. NASA has an API, and getting a key is like super duper simple. They just send it to your email. But if you're going to sort of use it for a project, so you're gonna do like a lot of API calls, then you do have to sign up for a developer key. I hope that answers your question. Thank you. Okay. Any other? We're good. I think we're good.
Hi, here.
Hi.
I'm curious about your education background. Do you have astronomy training, or I mean, I'm curious about how do you find this information? Because I am astronomy background, and in many years I promote astronomy education to astronomy people. So I'm curious, how do you find this information?
I'm sorry, are you the speaker for?
No,
Yeah, I really wanted to go to the talk. Thank you. Anyway, so I'm currently studying computer science, BS computer science, but I really, really wanted to go into aerospace. The thing is, like the programs for that aren't that good in the Philippines, and I needed to stay in the Philippines. But before then, prior to that, I studied at one of the top science high schools in our country. So that was sort of what really got me passionate into science. So we would take electives. We didn't really have an astronomy elective. What I took was like nuclear physics, which I think is your master's. I'm not sure. But so the information that I got is really sort of just digging into it, because that's really how you learn these days. For example, like computer science, the first language I learned was Java, and I hated it so much. So because it's so verbose. So I got into computer science only when I learned Python on my own. In the same way, I got into astronomy and sort of like these things by looking at the information that's available online. And I'm very, very thankful for that, because the Philippines is still a growing. So it's not the most gifted when it comes to like the institutions and stuff that I can go to. And so I'm very thankful that like there are resources online for this that make it accessible for me, even though I'm not in like a huge country with all of the like face-to-face resources.
Our session is about the everyone's well
welcome to come up and talk to her directly. So let's give her a big applause. Thank you.
Thank you.